Alright, in this video I'm talking about terminal points, terminal sides, and how we measure our angles and radians in a unit circle. So by definition, I've got the definition up here if you want to read through it. We are going to be looking for an ordered pair that is a certain distance around a unit circle. So I kind of want to talk about radians for just a second because right now it's just a measurement that we're used to using. We haven't really talked about where it comes from. So just really briefly, looking at the circumference formula for any circle, we've got a radius right here. Our radius in the unit circle is equal to 1. So that means that if our unit circle is drawn to scale, the circumference should be measured as 2 pi units all the way around. So that means if I took some kind of measuring device and actually measured the length of that curve drawn right there, it would have a distance of 2 pi units. So when we are measuring our radians, we're measuring the actual physical distance around the edge that we're traveling. And when you convert that to degrees, you're looking at, for that exact same point, how many degrees do we go through to open an angle from that starting point out to that same point. So radians and degrees are both describing the same terminal point, but they're two different kind of measurements for the circle. So let's just try a few, and I'll point out what the terminal point, terminal side, and all of that looks like as we go. So the first thing I'm going to do is, let's do pi over 4 radians. Okay, so starting at 1, 0, that's always where we start. If we have a positive distance, so if t is positive, we're going to measure in the counterclockwise direction. So here I'm looking at a t of positive pi over 4 radians. So I would take some kind of measuring device, start at 1, 0, and measure around the outside curve pi over 4 units. That happens to land us right here at this point. Now that we've looked at our unit circle for a while, hopefully you recognize that part. So if I measured that edge of the circumference, it should have a distance of exactly pi over 4 radians. Now, if we convert that to degrees, what we're doing is we're measuring from here, how many degrees do we open and cover to get to that exact same point. So if I measure here and shade this in, that slice of the circle should be exactly 45 degrees of that circle. So this is what we've labeled as pi over 4 or 45 degrees. Now notice that those were two different measurements, but they both led us to the same point on the circle. So we can convert between the two and still get to that same point. Now that point that we ended at, remember we're looking at a coordinate grid here. So this is a point in space. It has a definition. It has an ordered pair that defines exactly where it's located on the coordinate grid. Even if you didn't have the circle in front of you, you could still locate that point on the grid. That point is at root 2 over 2, comma, root 2 over 2. Now remember, that's actually just a number. That's a decimal. And so you could locate it on any coordinate grid by starting at the origin and measuring out that root 2 over 2 and up root 2 over 2. That is the terminal point for pi over 4. So when t equals pi over 4, the terminal point is the point in space where we stop after we've measured a pi over 4 distance around the circumference of the circle. Now, later on, you will need to know what a terminal side is, especially if you're trying to use the reference angle definition. So that I have in a separate video, but I'll be referring to this video in case you don't know terminal side. Terminal side is the side of that slice that is it's kind of like a line segment between the origin and that terminal point. And it's the side of the slice that points to the terminal point. This whole line right here is called the terminal side. So later on, when you're trying to measure reference angles, you need to measure the angle between that terminal side and the x-axis, and you'll need to know that definition. Now let's try this for a few other points just to kind of make my point. Let's try one that has a t that is negative. So when t is negative, you will move clockwise around the circle. That's the only difference. We're still measuring as if you had a tape measure and you're measuring the distance around that curve, but we're measuring clockwise. That's the only difference. So now let's try t is negative pi over 3, just to change it up a little bit. Okay, so again, we always start at 0 at the point 1, 0, and we're going to measure clockwise the distance around that curve until we get pi over 3 units around. So going down the curve as if I had a tape measure to actually measure that curve, we're going to measure pi over 3 units, and that's going to lead us to that point right there. And as we know from our unit circle, that point is 1/2 negative root 3 over 2. So the terminal point for t equals negative pi over 3 is 1/2 negative root 3 over 2. And then if we wanted to convert into angles, what we're actually looking at is what is the angle measurement that we open, what is the size of that slice, that angle that we go from 0 and we open up a certain angle. In this case, that angle would be 60 degrees. So this slice is 60 degrees of a whole circle. So if we wanted to convert between degrees and radians, 60 degree or negative 60 degrees, since we're opening down, is the same thing as negative pi over 3. And again, the terminal side is just that line segment made by connecting the origin straight out to the terminal point. It's the side of that slice. And then later on in the reference angle video, you'll need to find the angle between that terminal side and the x-axis. Now, one thing I do want to point out is that even though we talk about radians in terms of pi, it is just a decimal because it is just a distance around a circle. So in this case, just to give you an example, negative 1.047, rounded of course because pi is going to make it an infinite number of decimals, would be the same number of radians or the same distance as negative pi over 3. We would have to measure from 0, assuming that your circle is to scale. Let's say it's in inches, 1 inch out. You would measure down 1.047 inches around your circle. If your circle was built to scale in centimeters, you would measure 1.047 centimeters around that circumference.